Dear students, today we shall discuss inverse Laplace transform of derivatives. So the statement of the theorem is, if L inverse of Fp is equal to f of t, then L inverse of nth derivative of Fp is minus 1 to the power n t to the power n into capital F of t for n is equal to 1, 2, 3 and so on, which can be rewritten as L inverse of Fn of p is equal to minus 1 to the power n t to the power n L inverse of f of p for n is equal to 1, 2, 3 and so on. Now for n is equal to 1, this theorem is L inverse of f dash of p is equal to minus t ft, which is equal to minus t times L inverse of fp. Corollary 2 is for n is equal to 2, so we have L inverse of f double dash p is equal to t square ft, which is t square L inverse of fp. And for n is equal to 3, we have L inverse of f triple dash p is equal to minus t cube ft, which is minus t cube L inverse of fp. Okay, let's take few examples. The first example is evaluate L inverse of log of p plus 3 upon p plus 2. Suppose that this is f of p. So we have to find out L inverse of f of p, and now by using corollary 1, we have L inverse of f of p is minus 1 upon t L inverse of f dash p. Now because f of p is log of p plus 3 upon p plus 2, which can be written as log of p plus 3 minus log of p plus 2, so therefore derivative of this is 1 upon p plus 3 minus 1 upon p plus 2. So therefore L inverse of f dash p is e to the power minus 3t minus e to the power minus 2t. So therefore substitute the value of L inverse f dash p in equation number 1. We have L inverse of f of p, that is L inverse of log of p plus 3 upon p plus 2 is equal to minus 1 upon t e raised to power minus 3t minus e raised to power minus 2t, which is e raised to power minus 2t minus e raised to power minus 3t upon t. Next example, find L inverse of 1 upon p plus a whole square. Suppose that f of p is minus 1 upon p plus a, then what is f dash of p? F dash of p is 1 upon p plus a whole square. You can note that fp is, you find out integral of this, right? So if you find out integral of this, then we take that as fp, because when you differentiate f of p, you will get this as f dash p. So using corollary 1, L inverse of f dash p is minus t times L inverse of fp, which is equal to minus t times L inverse of, now f of p is minus 1 upon p plus a, so which is equal to t times L inverse of 1 upon p plus a, and which is t into e to the power minus at. So I have written in the bracket, take fp as integral of 1 upon p plus a whole square. Second method is L inverse of 1 upon p plus a whole square is e to the power minus at L inverse of 1 upon p square, which is obtained by using first shifting theorem, and which is e into e to the power minus at. Okay, let's take next example. Find L inverse of p upon p square plus a square whole square. Now if you integrate this, then you will get minus 1 upon 2 p square plus a square. So suppose that f of p is minus half p square plus a square, then f dash of p is p upon p square plus a square whole square. So therefore by corollary 1, we have L inverse of f dash p is equal to minus t times L inverse of f of p, which is minus t times L inverse of minus 1 upon 2 p square plus a square. Take minus half outside, so we have t upon 2 L inverse of 1 upon p square plus a square, which is tan upon t upon 2a sine of at. Next example, find L inverse of log of 1 plus 1 upon p square. This is similar to the first example we have done before. So suppose that f of p is this one, log of 1 plus 1 upon p square, which can be written as log of p square plus 1 upon p square. And now log of a upon b is log a minus log b. So therefore this is log of p square plus 1 minus log of p square. Log of p square plus 1 as it is, and log of p square is 2 log p. Now you differentiate it. F dash of p is 2p upon p square plus 1 minus 2 upon p. Now take L inverse on both sides. We have L inverse of f dash p is equal to 2 cos t minus 2. So therefore using corollary 1, L inverse of f p is minus 1 upon t L inverse of f dash p. Put the value of L inverse f dash p from here. So we have 2 minus 2 cos t upon t. Take 2 upon t common, we have 1 minus cos t in the bracket. Next theorem involves division by p. If L inverse of fp is equal to f of t, then L inverse of fp upon p is 0 to t f of u du. Okay, let us take example based on this theorem. Means if f of p is L inverse of fp is f of t, then if we divide fp by p, then L inverse of fp upon p will be 0 to t f of u du. Okay, let us take this example. Find L inverse of 1 upon p log of 1 plus 1 upon p square. So first of all we find out L inverse of this, and then we make use of this theorem because we are dividing here by p. Now since L inverse of log of 1 plus 1 upon p square is 2 upon t into 1 minus cos t, we have obtained here. So therefore L inverse of 1 upon p log of 1 plus 1 upon p square is equal to 0 to t f of u du. Now this is f of t, so therefore f of u will be 2 upon u into 1 minus cos u. So therefore answer is 0 to t 2 upon u 1 minus cos u du. Leave the answer in this integral form. Okay, let us take second example. Find L inverse of 1 upon p cube into p square plus 1. Now what is L inverse of 1 upon p square plus 1? L inverse of 1 upon p square plus 1 is sin t. So suppose that this is f of t. Now because we have got p cube here, so we shall firstly divide by p, then again by p, so we get p square, and again by p we get p cube. So we apply the above theorem 3 times. Okay, so L inverse of 1 upon p p square plus 1 is 0 to t f of u du, and f of t is sin t, so therefore f of u is sin u du. Integral of sin u is minus cos u, but the limits we have 1 minus cos t. Again dividing by p, L inverse of 1 upon p square into p square plus 1 can be written as L inverse of 1 upon p into 1 upon p into p square plus 1, which is equal to 0 to t. Now from here we have 1 minus cos t, so we write down here 1 minus cos u du. Integration of 1 is u, integration of cos u is sin u. Put the limits from 0 to t, we get this as t minus sin t. And finally L inverse of 1 upon p cube into p square plus 1 is integral 0 to t f of u. Now what will be f of u here, because f of t here is sin t minus sin t, so f of u is u minus sin u and then du. Integral of u is u square upon 2, integral of sin u is minus cos u, minus minus becomes plus, limit 0 to t. Put the limits, we get the answer as t square upon 2 plus cos t minus 1. Third example, find L inverse of 1 upon p into p plus 1 whole cube. Now we can write p as p plus 1 minus 1. So that we have here p plus 1, and in the here also we have p plus 1 whole cube. So we can make use of first shifting property. So we get e to the power minus t L inverse of 1 upon p minus 1 into p cube. Now find out L inverse of 1 upon p minus 1, which is e raised to the power t, and divide once by p. We have L inverse of 1 upon p into p minus 1, which is equal to 0 to t e to the power u du. In place of t we have u here. Put the integrate and put the limits, we get e to the power t minus 1. Again dividing by p, L inverse of 1 upon p square p minus 1 is 0 to t e to the power u minus 1 du, which is e to the power t minus 1. And finally, once again dividing by p, we have L inverse of 1 upon p cube into p minus 1, which is 0 to t e to the power u minus 1 du, which is e to the power t minus t square upon 2 minus t minus 1. Okay, let's take the next example. If L inverse of p upon p square plus 1 whole square is t upon 2 sin t, find L inverse of 1 upon p square plus 1 whole square. So we have to find out L inverse of this. So we start with this L inverse of 1 upon p square plus 1 whole square, dividing by p and multiplying by p. Now what is L inverse of this? This is given to us as t upon 2 sin t, and because we are dividing here by p, so we make use of the above theorem. So this L inverse of this is equal to 0 to t u upon 2 sin of u du. And now integrate it by parts, put the limits, we have half into sin t minus t cos t. Now let's take the last example. Find L inverse of 1 upon p into p square plus 2p plus 2. Now make this as perfect square. We have L inverse of 1 upon p plus 1 whole square plus 1. Then using first shifting theorem, we have e to the power minus t, L inverse of 1 upon p square plus 1, which is e to the power minus t into sin t. And now because we are dividing here by p, so therefore L inverse of 1 upon p into p square plus 2p plus 2 is equal to 0 to t e to the power minus u into sin u du. And now integrating it by parts, we shall get the answer as 1 by 2 1 minus e to the power minus t into cos t plus sin t. Thank you so much.